Hi, Math 30-1s. Continuing on with trig functions today, lesson 9. The next 2 days are going to be problem solving type scenarios associated with the equations of trig functions. The difference primarily being that today they will provide the equation of the function that we're studying and solving. Next day's lesson, we will also have to come up with the equation ourselves and then kind of go through the same process. So today's a little bit easier. I'll explain and obviously highlight all the important tips, points, things we want to focus on moving forward with problem solving. Okay, so it says a function whose graph resembles a sine or cosine curve is called a sinusoidal function. The graph of a sinusoidal function is called a sinusoidal graph. Many periodic phenomena have sinusoidal graphs. So examples are the time of sunrise is a function of the day of the year. The height of a chair of a Ferris wheel is a function of time. The depth of the ocean due to changing tides is a function of time, etc. So in this lesson, the equation will be given. In the next lesson, okay, like I mentioned, we will have to come up with the equation. Most of the equations will be functions of time, and the variable t will be used. The period of the graph will be in time units. Graphical methods will be used to solve and determine suitable windows is an essential feature of this situation. So you'll see what that means here as we move forward, okay? I'll explain that to you and you'll see the portions of the questions that deal with that. So the first question reads like this. The depth d meters of water in a harbor t hours after midnight can be approximated by this function. D of t is equal to 12 plus 5 cos 0.5 t, where t is between 0 and 24. So again, some really important things right away, okay, in that question. So the first thing I always like to do or kind of understand is what's going on which axis so I can better understand the situation. Now, based on the equation, d of t is where my variable y normally is. So that means d, the depth in meters, okay, is going here. Depth in meters, and I shouldn't have m in there. Okay, it is d of t, so it's the depth at a specific time. It's measured in meters, so that's like your y variable. Inside the equation where x normally is, we have t, so t is where x normally is. Okay, that equation goes, or that variable goes there. Now we look at the domain, and they're saying time is only going to exist between 0 and 24. Well, that's hours, okay, so that's 1 day. And the other important thing you always want to know is that t hours after midnight, right? They tell you that in the question. So when we're dealing with time in these questions, we're always dealing with a 24-hour clock, okay? And that's important. What that means is that if you get an answer, for example, of time 13, well, that's 13 hours after midnight. That's 1 p.m. in the afternoon. So 24-hour clocks are something that we deal with in these questions, okay? Please make note of that. Now, the other thing that I would like to point out is that that equation looks a little weird to us, and it's just because they have that number 12 before the 5 cos. So if you prefer, you can rewrite that equation so it looks a little more familiar to you. D of t is equal to 5 cos of 0.5 t. I'd put that in brackets because then we add the 12 after. So I've just moved that 12 after. So now what I can see clearly is that this is the a value, this would be my b value. There is no C, no left or right phase shift, and this is the D value, okay? So now I know what my values are, okay? A, B, and D. So going back to last day, that's what A attacks here. It says determine the max and min depths of the water in the harbor. So if you remember from last day, okay, the max and the min had special little equations that we came up with. So max was the A plus D, and the min was negative A plus D. So when I take those values, the max will be 5 plus 12, and the min will be negative 5 plus 12. So this will give me 17, and this depth was in meters, and this will be 7 meters. So my graph will only exist between 17 and 7 in terms of a range. Now the period of the function, okay, what's the period of the function? Well, how do we calculate that? Well, when I have the equation, it's pretty easy. I take the normal period length, which in this case is the graph of cosine, that's 2 pi, and I divide by the b value that's given to me in the equation. So it's 2 pi divided by a half, so 1 over 2, and you multiply by the reciprocal, you will get 4 pi. So it's 4 pi, and those are hours, aren't they? Because we're talking about time here. So there's the period length. It takes 4 pi hours for this graph to do one complete cycle. So write a suitable window which can be used to display the graph. Well, that comes down to the range that I just calculated and the domain they gave me in the question. So for the x's, the domain, I would have 0 hours, that's midnight, all the way up to 24 hours. Okay, and your scale can just be 1 hour. Every tick you see on the x-axis could be 1 hour. If you prefer 2 hours or 5 hours, that's fine. But it's the 0 to 24 that's a big deal. Remember, the first number is your minimum, the second number is your maximum, the third number is your scale. Now the y values, or the range, that comes from the max and the min calculation I did right there. So I'm going to go a little bit below 7, so say 0. I'm going to go a little bit above 17, like 20, and then again, the scale can be 1, not a big deal. But I always want to go a little below the minimum, a little above the maximum, so I get a clear idea of what that graph looks like. So in D, it says, what is the depth of the water to the nearest tenth of a meter at 2 a.m.? So 2 ways to do this. If I want to solve algebraically, 2 a.m., this is a time, isn't it? So I would be substituting t equals 2 into my equation. So simply the equation would look like this. D at t, which should be 2. So I can replace that with 2. So the depth at 2 would be 5 cosine of 0.5 times 2. And then you would add 12. So how do we do that? We have to do this first, then go cosine of that value, multiply by 5, and then finally add 12, okay? And when I do that to the nearest tenth of a meter, okay, I'm going to get 14.7 meters. Okay, so try that, make sure you can do it. Again, your calculator should be in radian mode, okay, at this point. If I were to graph this, this is what would happen. So when I go and graph this, okay, I would be graphing my 5 cos of 0.5x plus 12, and I would get a graph that looks something like this. Okay, so down, down, okay, and up like so. Okay, that's what that graph is going to look like. Okay, so what is the depth of the water at 2 a.m.? So all you would have to do is go trace, enter an x value of 2, and what you'll get, okay, therefore, is a y value that equals 14.7. Okay, so it'll give you the same thing using your calculator, okay, if you want to do it on your calculator versus algebraically like I showed it below. Remember, with these questions, they can only kind of do one of two things: give you an x value and ask you for the y, or give you the y value and ask you for the x. So in D, the one we just did, they gave me the x value, which is the t in this scenario, and they asked me for the y value, which is the depth. Now in E, this is what they're going to ask me. They're going to go the other way. It says a ship requires 8.5 meters of water. Okay, so it needs 8.5 meters of water it is in the harbor at midnight. By what time to the nearest minute must it leave to prevent grounding? So what I'm going to do is this 8.5 meters of water is a depth. So I'm going to go and I'm going to graph a second function at 8.5. So I graph a second function of y2 is equal to 8.5, and it would look something like this. Okay, remember on my graph, the highest this graph is going is 17, the lowest it's going is 7. Okay, so 8.5 is going to be about there. So when I do that, I graph the two functions as follows, right? Again, I graph y1 as my first function, which was the 5 cosine of 0.5t plus 12. And then I would go and graph y2 as 8.5. And I want to know where they do what? Intersect, right? I want to know where they intersect. That's what I'm interested in this case. So remember that they're saying at midnight, which is at time 0, right? That's where midnight is. And it has to have 8.5 meters of water to prevent grounding. So anything above the blue line is good. Anything below it is not, because there's not enough water. So I have to leave, if I'm talking about this graph, I have to leave anywhere in here, because this is where the water is above 8.5. So what I'm interested in is this intersection point, and then I want to leave before it. So when I find the intersection point, I find that they intersect at an x value, so right here, okay, they intersect at an x value of 4.6923, etc. Okay, now they want to know the time though. This is 4.6 hours, isn't it? So this 4 that I'm underlining is 4 hours. What I need to figure out is what the 0.6923 is in terms of minutes. So you're going to go 0.6923 times 60 minutes, okay? And that'll tell you how many minutes of an hour that is. So when you do that, that gives you 41.54 minutes. Okay, so you're going to have to round down, because if you round up to 42 minutes, the water will be too low. You have to round backwards in this case. So that's going to be 4 hours and 41 minutes. So therefore, that time is 4:41 a.m. That's what time you have to leave to prevent grounding. Now in F, it says, what is the next time the ship can return? So the ship cannot return anywhere down here. Okay, the water is too low. The next time the ship can return is at this intersection point right here, just above it. Okay, that's when it can return. So I need to know this time, and then I actually have to be just a bit above it so that the water is high enough. So again, you're going to do the same thing you did before. You're going to find the intersection point of those two graphs, but this time we're after this point right here. So what I find is where they intersect. Okay, so second function trace intersect. And this time you'll find that they intersect at an x or a t value of 7.8739, okay, and again, etc. What I find from that calculation is that number 7 is 7 full hours. And then I got to use this to figure out how many minutes it is. So again, 0.8739 times 60 minutes. And when I do that, I get 52.43. Now that's where they intersect. If I go down to 52 minutes, it's too low. This time I have to round up. So it's going to be 53 minutes so that there's enough water. So therefore, that time is 7:53 a.m. Okay, so in E I had to round down, and in F I had to round up. Not based on our standard rounding rules, but in this case, in terms of logic. What makes sense? At what times do I have enough water? At what times do I not have enough water? Okay. Next page, and second question, this is it for today. Pretty short, and then it's just a lot of practice. So in a certain town in Alberta, the time of sunrise for any day can be found using this formula. Now, this formula, again, is interesting. One thing I want to mention before we go again is we're going to talk about time here. So again, time is going to be a 24-hour clock. So just like in the previous question, if you get an answer, in this case, say 14, that's 14 hours. That after midnight, that's going to be 2 o'clock in the afternoon. Here's the interesting thing in this question, though. If you take a look at this, 2 pi over 365, that is your B value, okay? A lot of times when we're finding the B value, that's the calculation we do. Sometimes in these word problems, they leave it like this. They don't simplify it, okay? So in our word problems, sometimes you will see 2 pi over 365. That is your B value. That's your B value in this question. A is obviously the negative 1.79. You have D minus 78. Okay, so that's your phase shift. So that would be 78 units to the right. And then you see plus 6.3, that's your D value. So the graph is going 6.3 units up. But the tricky one is that the B, sometimes they write as 2 pi over 365. They don't simplify it. So they leave it like 2 pi over 365. Okay. So it says write a suitable window which could be used to display this function. So again, just like in the last question, they leave a little bit out this time. I want to know the max and the min value. So how high and how low this graph go. So if you take a look at the max value this time is basically negative. So I'm going to have to go negative A plus D this time for the max and A plus D for the minimum. Okay, and that's because the A value is already negative here. So when I do that, negative A plus D here, I will get 8.09. And when I go A plus D, I'm going to get 4.51. So that's how high and how low the graph goes. That's going to be my range. Now, they're talking about, in this question, days for a year. That's going to be what's on my x-axis, right? So again, when you take a look at this question, okay, if I were to label the axes here, I would have T here on the y-axis, and I would have D here, okay, on the x-axis. So days are your x's, and we're talking about days of a year. So I'm probably going to be interested in a whole year, 0 to 365. So when I go and list my domain, the x's, I would be from 0 all the way up to 365, okay? And you can make your scale whatever you want, 1 day, 5 days, whatever, doesn't really matter. The range comes from these two values, the max and the min that I calculated. So I'll go a little below the min, I'll go a little above the max, and I make the scale 1, okay? And there you go. So there's your domain and range in terms of what you would put in for your window settings on your calculator, okay? And following the pattern that we did with the last question, there's only two things they can ask. They'll give you the x, solve for the y, or they'll give you the y, solve for the x. It says use the formula. So this time they're saying use the formula, don't graph, to determine to the nearest minute, so the whole minute, when the sun rose on May 7th, the 127th day of the year. So what you're going to do is you're going to put 127 into the equation for D, okay? Because that's day of the year. So when you do this calculation, okay, it's going to look like this. T is equal to, you're going to have negative 1.79 sine of, okay, this big calculation, 2 pi. Now you have 127 minus 78, okay, over 365. Sorry, it's a bad 365, and then plus 6.3. So what has to happen is you need to do this whole calculation first, then take the sine of that value, then multiply by negative 1.79, and then finally last add 6.3, and make sure your calculator's in radian mode. Okay, when you do that, okay, you will see that they intersect, okay, or sorry, that you get an x value that is, like I said, 127. You put that into the equation, okay, which in this case is your D value, and the y value, okay, will end up being 4.96292, okay? So that's your y value. So just like in the last question, that's your y value, which is t time in this question. The 4 is 4 hours. We have to figure out the 0.96292. So you're going to, just like in the last question, go 0.96292 times 60 minutes, okay? And to the nearest minute, that's going to give you 58 minutes, okay? So therefore, that is 4:58, and that's a.m., okay? So there's your answer. C says determine on which days of the year the sun rose at 7 a.m. Now this is a time, isn't it? So what you're going to do is you're going to graph two functions here. You're going to graph a second function now, that is 7 a.m. And you're going to find where y1 and y2, again, intersect. Okay, you want to see where those graphs intersect. Okay, so you'll see that they intersect two places. Okay, they intersect at 54.659, etc. And they'll also intersect at 283.840, etc. Okay, that's where they're going to intersect. So on which days of the year is that? Well, this is day 55, okay, on the 55th day, okay, because it's the 54th day and a bit, so that's the 55th day, and then it'll be on the 284th day, okay? So there are the 2 days, and that's it for that lesson, okay? So again, be very careful of a couple things. Time is in the 24-hour clock. Okay, we have to know how to find the max and min values from the equation, okay, a plus d, negative a plus d, so that we know what the range is and we can use the appropriate window settings. We have to know how to graph, okay, so and find the intersection points, how to find time, okay, in hours and minutes, so we know the exact time. And the other thing is, like I said up here, a lot of times the b value will be written as 2 pi over 365 or 2 pi over whatever value, okay, instead of them simplifying it. They've just written the calculation inside of the question, okay? So the b value sometimes isn't absolutely clear. You saw in the first example it was. In the second example, they left it as 2 pi over a value, okay? And that was your b value, but also your period, which is the 365, right? Because it's 2 pi over the b, over the period. So your period in this question is 365. Okay, so practice that tonight and tomorrow and see how you do. Any